Hi everyone, welcome to the Data Science Career Track info session. Today we have Tristan Markwell from Providence St. Joseph who will be talking to us, he's a data science manager, and will be talking to us about data science at Providence and talking about what kind of positions his company is hiring for and what do they look for in data scientists. All right, over to you, Tristan.
All right, great to be here. I'm super excited. I'm the program manager for data science and advanced analytics, so it's my job to kind of advance data science and analytics in general throughout the organization. I want to talk a little bit about where we're at and give you some specific examples of the things that we're working on. So let me just get this working. So Providence St. Joseph is a big health system in the West. We've got 50 hospitals and go from Anchorage, Alaska, all the way down to Southern California. So we've got an awful lot of doctors and hospitals and clinics and a health plan, and it's an opportunity to really have the work that we do impact a whole lot of patients at once. And specifically, this is where our data science program sits at the moment. We're the data science program for just the Providence side. The St. Joseph acquisition is happening as we speak. And so we're within the operations level, and then the information services sits in that, and then healthcare intelligence is like the data and analytics shop in general, including reporting, and we're a piece of that program. So combined, we have 100,000 caregivers, so there's quite a bit of bureaucracy, but we have an opportunity to meet with and influence executives all over the organization. And we deal with a lot of domains. Basically, we deal with anything where they don't have their own specialists or their own data scientists. So, for example, we have worked in clinical. We've worked with some problems like sepsis, that kind of thing. Although often the deep clinical areas like cancer research, genomics, those will have their own special data scientists or analysts, biostatisticians that do work on there. We do a lot of work operationally, we've done work with clinic no-shows, hospital readmissions. Those are perfect examples. We've done financial stuff like denials of claims. We are working on some projects to help understand why there's variation in cost and outcomes in surgeries. And we do things like just working with, say, our community partners to say, okay, how do we know where there's social need, all this kind of stuff. It's pretty broad. And that's our breadth and our depth in terms of what we can contribute. We do work on formal analysis like research studies and papers for journals, which is more the traditional statistical realm. We also do prediction work, predictive analytics, and I'll show you a little bit of that. And that's the traditional, what people often think of. First, I think of data science, but we do a lot of other things, right? So with some of our work, we might be identifying where the outliers are so that people can take action on them, right? So it's like, this is a surprising result from a financial point of view. We need to dig into that. We might be able to take our algorithms and build them into calculations. So for example, this is how many no-shows, what the no-show rate risk would be. And so this is how many no-shows we think we've prevented, and this is how much money we think it's generated. Similarly, we can use risk score thresholds to trigger events, and so that's kind of live going out, streaming rules for coming in, for saying like, these are the rules under which these things should be triggered, and all of that we have a say in, we have a stake in. In terms of our tool set, SQL is a must because we need to pull the data out of our systems. We are moving toward a data lake in the cloud, and so the tools will be different there, but we're, I think for legacy reasons, working with a lot of things that have similar SQL structure, so like Hive kind of stuff. For general data work, we're using R for the predictive stuff as well. We use Python as a specialty tool for natural language processing with NLTK and GenSim. And then we've used a few other pieces just to fill in gaps. We've used Julia for some process mining and some other things, and those are the sets of tools that we use in our team. I want to show you two things that we've been doing. These are both from our, we're building an integrated platform that is an app store that is used internally. And so let me just pull those up. So the first one is a traditional predictive analytics project where we've got, perfect. We've got we're serving up this predictive algorithm that rates patients on how likely they are to no-show for their appointments. And it's just a general purpose app you can use for, seems like it's interfering with the sharing software, but where you can call patients based on their risk. In this case, what we've got is the ability to just mark what you've done so that other users will not call the same patient. Also, then we have the record of who was called, and we can say, hey, this is how effective we think your calls are, or again, this is how much money we think that you're generating from these calls in terms of appointments that aren't missed. Or often it's appointments that we know earlier that the patients aren't going to be able to make it because we called them, and then we can fill those with another patient. So that's one example of just traditional, like serving up predictive analytics. In this case, what we do for the data science team specifically is we built the process that generates the model and that scores the patients daily. And then we had front-end developers working in JavaScript to build the rest of it. And then let me get the other example. So this is the other example. This is an app to look at mental health in Southern California. And so we've got a few different pieces. One is we do have the Twitter feed that's updating live. You can see that it's got the location piece as well as, so this is things that are relevant to mental health or other socioeconomic factors in Los Angeles geographically or from trusted mental health accounts. And so you can see there's the larger piece here of just the feed down in the bottom, as well as the map. The map also has two other pieces. It's got this piece. So we built the Twitter feed. We built this map piece in terms of not building the map itself, but we not only pulled in the data and calculated it that determines these values for either the density of need, socioeconomic stress in the area, but also we built, we're the ones just based on our understanding of the data that pulled from the census files, the coordinates, and built the shape files and that were used to generate these pieces of the map. The last piece that it also has the resources. So we got internal, the Providence and St. Joseph resources, as well as external resources from the government. So those are the kinds of things that we work on in this. And again, the actual map and the front end and all that were built by our development team rather than the data science team. So right now we actually have two job openings. Probably for people starting out, the senior data scientist position wouldn't be appropriate, but I mean, we're happy to talk to anyone about that meets those criteria. We're looking for like 7 years of experience, so that kind of work with data analysis and predictive modeling and all that kind of stuff. Whereas the internship is perfect for people who are just starting out or who are trying to finish education or whatever. That's going to be a summer term for like a 3 or 4 month internship in the summer. And we're looking for someone who has something interesting and exciting to offer that could work on an independent project and do something really impressive. So it's really kind of a fun opportunity. We had interns last year, and one of them kind of drifted toward like the development side of it and built a lot of cool things. Like he built most of the map stuff that you saw. The other one took a real NLP focus And we ended up hiring him because we decided we couldn't live without him. Even though that's not, usually a successful internship means you've got a good recommendation, you move on, but we just had a really great experience. So I'm excited for this year's crop of interns. And right now we have one position open. Hopefully, I'm trying to get positions open in like allied sides, like the development and the back end database stuff. So that's the presentation. That's what I had in terms of sharing, just so you could see a bit of what we do. And I'm happy to take any questions.
All right. Shri, if you have any questions, feel free to ask. I have a couple of questions. So one thing I noticed that the way some of the things that you do in terms of the data science work is that you use R for some of the analytics, you use Python for NLP, and you also mentioned things like Hive and some of those tools. So a lot of the times our students, especially those from Springboard, we focus a lot on the data science part, not so much on the data engineering. We do a little bit of Spark and so on, but not that much of a focus. So they always find when they go out and look at data science job descriptions, they're like, oh, I don't know any of these technologies like Hive, Spark, and so on. So how important is it for a student starting out to know those technologies versus learning those on the job?
So the real product, right? The real end result are these data products where you've got these informed decision-making tools, and that requires, for an interface, right, you need full stack development off of either a database or a cloud service, and you need the data science to inform it. And it's very rare that you find a single person that has all those skills.
Yeah.
And so the question is, where is the team strong enough that you can where do you kind of connect there? And so that's, for us at least, we've found that we've filled in a couple of gaps, especially around that might be more engineering focused, right? Like connecting to APIs is something that we have just more experience in than a lot of the developers or engineers.
Yeah.
As well as dealing with geographic data is another one, and just kind of cleaning that up. Another example is we wrote the C#. One of our colleagues wrote the script that worked with Bing to geocode the addresses of all of our patients every night, so that we would have like a full set of geocoded patients with as the data updated. So that's something that's a very data engineering task, where we filled in the gaps basically.
Yeah. Okay. Cool. So you mentioned Python and NLP, and that got my attention a little bit because I do a lot of NLTK and I really enjoy it. Can you give some examples of NLP projects that you guys have worked on?
Yeah, let me give you an example of something that's small and practical, and something that's big and we're trying to figure out exactly how to use it.
Yeah.
So the small one is we've got a project where we're looking for, again, I mentioned the variation in surgery outcomes and costs. And so some of the times the things that are relevant, and I'll give you the example of a spinal fusion,
Yeah.
they don't exist in the structured data. So for example, one of the most important things to know about a spinal fusion when you decide how expensive it should be or what the outcome should be is how many levels of the spine were fused, right? Because it kind of just is like the magnitude of the surgery.
Yeah.
And so that only exists in the operative notes.
Yeah.
And so that was a combination of basically some regular expression rule-based approaches bootstrapping up to a neural network model.
Yeah.
And so that was one example that was really practical, and we're still kind of working on getting the accuracy of that higher and higher so we can use it regularly. The larger example is we were looking into readmissions, and so we took all of the chart notes, and it's like the volume is like 10 times the size of the English language Wikipedia or something.
Yeah.
And we ran Word2Vec on the whole thing.
Oh, okay.
And to get a sense of the a three-dimensional vector representation of all the words in our notes. And then we did spherical clustering to get 50 clusters of words, and then looked at so what percentage of the patient's notes in that hospitalization were in each of the clusters, and how can we use that as features to predict readmission.
Okay.
We've taken that work and spun it off to using it on all notes to make a fast search. We use like
Yeah.
build on Solr, where it's not only just doing a Solr search, but it's also feeding similar terms from the distance from WordDivX so that you can
Okay.
quickly search through notes with synonyms, that kind of thing.
Okay. Cool. Awesome. So tell us a little bit more about your hiring process for data science.
It's slow and bureaucratic. There's a link to our hiring site, and you apply, and you might hear back if you pass the hurdles from the recruiter's side, and if you hear back, then you might get a call. And I mean, it's not great, honestly, but it's a high fence, but it's like an English walled garden. It's a high fence, but it's lush on the inside.
Yeah. So say someone gets past that first hurdle and actually gets to a recruiter and all that, what are the next steps?
Yeah, so there's talking to the interviewer for the recruiter for a phone screen, and then there's a phone interview, and then candidates are the top candidates have like an in-person interview.
Mm. What's covered in the in-person interview? What kind of topics?
Oh, sure. So the interviews are not so much like coding questions, like the kind of horror stories you hear about from like Google interviews, that kind of stuff. That's not really what we do. The biggest thing is behavioral-based interviewing. So it's all about, here is a critical kind of like a cultural behavior at Providence, or this is how we, handle situations. And so like, give us a situation where you felt rushed and, and you couldn't do as good a job as you wanted to do. And what was the situation, and then what did you do, and what was the outcome? So it's very much that being able to distill your entire history into stories that you can tell that illustrate how you handle the work.
Interesting. So all of the on-site interviews are behavioral, and are there any technical interviews?
Well, there's a technical component. It's not like there's no coding piece, but it's very much, like I want to hear about people's experience with languages and with coding, and one of the things that I'll do is I'll keep pushing based on what I know, and kind of like an oral exam, you keep asking questions until you figure out where the boundaries of their knowledge are.
Right. I agree. And one of my favorite ways to interview data scientists is ask them to describe a project they've worked on and do the same thing. We just keep pushing, like, why did you do this? Why did you do this?
Yeah, one of my favorite questions is to ask people about something that they think is really impressive, that they're really excited about having done, and just explain why they think it was exciting.
Yeah.
And because then you get not only hopefully that they're talking about really working at the edge of their skill set, but also you get to hear a little bit about their passion and why they're interested in the field.
Yeah. Cool. That's wonderful. So in terms of finding candidates for your roles, what are some of the things that you have the most, either like candidates always seem to struggle with, or the things that are hardest to find in candidates? Are there things like patterns that you notice there?
I think especially we've struggled to some extent because the intersection of people who have this new skill set, especially just the combining of like the statistical intuition and the programming ability, and the intersection of that group with the group of people that's interested in working in healthcare is kind of small.
Oh, okay.
And especially when you're talking about people with experience, most people with healthcare IT experience are very much like old school, dealing with 20 years ago technology that, we'll still have 15 years from now, but that's not the only thing that we need to be doing.
Okay, interesting. That's really interesting. We always have students who show up. They're not very frequent, but some of our data science students who show up with like, I want to work in healthcare. So if there's anyone that shows up, I'll definitely send them your way.
Yeah.
All right. Well, that's all from me about questions. If there are no other questions, then thank you so much for the time. And as I said, the recording will be added to the community, and you'll be added to the community for a bit, so students can ask more questions.
Great. I'm looking forward to it.
All right. So thank you so much. Have a great day.
You too. Bye.